And welcome to today's webinar, Top Tips and Tricks to Improve Your Condition Monitoring Program, brought to you by CBM Connect. I'm Paige Hattie, the Director of Mobius Connect, and I'll be your host for today's session. Now, before we get started, there's some important information that I'd like to share with you. This webinar here today is being recorded, and you'll be emailed a link with access to the on-demand version of this webinar tomorrow. The recording of the webinar will also be shared on CBM Connect, so feel free to pass it along to your colleagues if they weren't able to join us here today. So first, I'm pleased to share with you the Mobius Connect community platform. The Mobius Connect community is all about you, providing you with the space and the technology where you can connect with the right people and resources that are all intended to help you solve problems, continue learning, and to give you a place where you can share your experiences too. So once you've gone ahead and created your free profile, similar to how you would on LinkedIn or any other professional networking site, you can start connecting with other industry professionals wherever you are in the world in any language. Mobius Connect includes fun features like the industry's live feed, forum discussions, interactive connection finder map, direct messaging, customized communications, which are all based on your specific areas of interest, global events, jobs, and news listings, and a mobile app, which you can get in the Apple and Google Play Store. You can also continue your educational journey live with the Connect conferences or online through the Connect knowledge base. And you can even become a member of your regional Community Connect group to gain access to additional resources and attend live and more virtual meetups with professionals from your area. And you can get started by creating your free profile and joining the community if you haven't already at mobiusconnect.com, and I hope to see all of you there. And then I'd also just like to take a moment here before we get started to thank our team at CBM Connect for producing today's webinar. CBM Connect is the leading online educational community, which is published by thought leaders and experienced industry professionals like the folks we have on the line today, who are from all over the world with a dedicated focus on each of the condition monitoring technologies. CBM Connect allows you to organize content based on your specific areas of interest, which can include topics like condition monitoring management, alignment and balancing, lubrication, motor testing, oil analysis, thermography, ultrasound, or vibration analysis. And you can get started on CBM Connect by going back and creating your free profile on Mobius Connect and then selecting which topics you'd like to stay up to date with. And you can also choose to visit cbmconnect.com directly to access hundreds of on-demand webinars, interviews, videos, white papers, and more. So that being said, if anybody has any questions throughout the webinar here today, go ahead and type them in the question panel on your GoToWebinar screen. Today's session is all geared and focused towards our audience, all about you. So our panel of experts here is more than happy to answer some of your questions throughout the session today. Thank you to those of you who submitted questions in advance. We look forward to taking some of those and answering them. Just as a heads up, all questions will be answered on the air anonymously, so no need to worry about getting called out directly. And if we happen to run out of time and don't make it to your question, I want to assure you that we will share all questions with our panelists, and someone will be sure to circle back with you after the webinar is completed. So that all being said, it is my pleasure to introduce you to your moderator for today's panel discussion, DJ Reesman. DJ is a solution architect at AssetWatch, and DJ has over 10 years of experience in manufacturing and automation and has worked with more than 500 facilities in a broad range of industries to improve quality, safety, and OEE. At AssetWatch, he specializes in evaluating best practices for reliability and maintenance for new clients, helping them to pinpoint the best strategies and optimal plans to implement predictive maintenance smoothly. In this webinar, we'll be focusing, like I mentioned, on all of your biggest questions when it comes to improving your condition monitoring program. And we also have our panelists here today, Jaidev, Chris, and Eric, who'll be working with DJ to answer your questions, all from the AssetWatch team. So that being said, DJ, I'm going to go ahead and pass the presentation on over to you now.
Thanks for everybody coming. So we're pretty excited to chat with you guys a little bit and talk about, predictive maintenance and condition monitoring. So today's agenda, to review a couple different maintenance common practices and strategies that we see all across the industry. Talk about predictive maintenance more specifically and why it's important. Talk about the power of having a condition monitoring engineer, whether it's on staff or a third party one. And then talking about real world examples where predictive maintenance was very effective across all different types of industries. Then after that, excited to have that Q&A with you guys. I appreciate everybody who's already sent some questions in ahead of time, but then everybody that, if you weren't able to do that, can't wait to hear what you guys got going on after that. Cool, so just to kick us off, first thing I like to do is do a poll question. So based on what everybody's doing right now, I want to open up a poll real quick. I'd love to hear, are you guys doing reactive maintenance strategies, preventative maintenance strategies? Maybe that's a lubrication route or a PM type schedule. Predictive, where you guys are utilizing, vibration or temperature monitoring or different tools on the market to be able to catch things ahead of time, or even reliability centered maintenance. So Paige, if you could please open that poll, I'd be interested to hear what everybody's doing right now. So we'll open this up for about 30 seconds or so. I know we got a wide variety of industries and people on here, so I'm interested. I think I have a gut feeling what I think most people are going to say, but excited to see if I'm right or wrong. Perfect. Cool. Predictive. Wow. I would have guessed preventative. So very, very excited to see a lot of people on this call are ahead of the game, and it's probably not surprising considering y'all are taking time to learn more. Great. Well, naturally, when it comes to predictive, there's a lot of different tools out there on the market, and I'd say really in 2023, no one should be reactive anymore. Whether it's vibration, lubrication analysis, ultrasound, thermography, there's too many different ways to catch different types of failures in your facility. So if you're waiting at the point you can hear it or smell it, you're probably costing yourself a lot of money. And that's really where the industry started going, 10, 20 years ago. And I think it's really accelerated the last 5. So naturally, what we all want to do is figure out how we can be on the left side of this page and not so much on the right side. It's really interesting because Forbes actually did a study about a year ago, and they found 82% of companies have unplanned downtime. They've reported at least one or more, which, let's be honest, I know most facilities, if they only had one a year, that's actually probably a pretty good year. So, but unfortunately, a lot more of us are having those costly failures, and those could be $10,000, $20,000, if not in the six figures. So here we'll kind of talk about on the next slide, different ways we can be proactive about that and the benefits of it. So why is predictive maintenance important? It's glad to see that almost half of you are already in this space in one form or another. So naturally what it does, it helps reduce overall unplanned downtime, helps you optimize your team's performance. Post-COVID, many factories are very short-handed. So if we can make sure that we're getting the best use of our team's times, we're naturally going to be a heck of a lot better off as a group. Decrease kind of facility and maintenance costs. Naturally, if you catch something like a bearing failure well before the motor burns up, you're going to be saving a lot of money and it's helping that bottom line. Not only that, being able to predict things when they're going to go wrong as opposed to having to stock very expensive equipment on the shelf is going to make you guys a lot more effective and help with those budgets. Then lastly, making data-driven decisions and processes, not just, oh, we did it every, we go do a lubrication schedule every month just because somebody decided that's what we should do. Well, it's probably not going to be very effective in the long run. And I think Chris here on my panel has a really good case study of a team that was doing exactly that and why it wasn't working out well for them. But that's why predictive maintenance is so important. The other common question, we as a group get from a lot of people is, when it comes to reliability, should we really be investing a lot of money and stuff into AI or machine learning or the digital side of things? Or do we still need that human element? And quite frankly, what we've found and what the industry's proven is you still need a bit of both. Yes, technology has come a long way, but it's not necessarily caught up to the point where you can completely rely on one or the other. One of my favorite examples of this is we were working with a company and we were talking to the maintenance manager. We're doing a year-end review and realized in 2022 they went through the same exact coupling 8 times in 1 year. Wild. And yes, the AI and the machine learning could easily point out to them, hey, you're having a coupling issue. We recommend you doing X, Y, and Z, fixing it, switching it out. But what they weren't able to figure out that one of our human CMEs were actually able to figure out is they started talking to the maintenance manager and find out, hey, we don't believe in laser alignment, only straight edge alignment. Well, shoot, right there's already a big problem, right? And what we end up finding out is he's just always done it one way. He's convinced that will always work. Well, we got that to higher up team members in a very polite manner. And guess what he got for Christmas? A laser alignment tool. Guess what issue that plant hasn't had in 4 months that they had 8 issues of last year? They have not had a coupling go out. So that's one of those great examples of how that human element is so very important, even though the technologies come in leaps and bounds. Technology can really help you identify issues, but it can't always help you identify the root cause, and vice versa. If you rely on only human power, there's way too much data we're getting back from our factories now in our manufacturing processes for one person or even a small team to go through. And that's where technology and AI can be really huge. Yeah, today I got some great experts. I actually have our VP of condition monitoring and 2 of our most senior condition monitoring experts. So they all have well over 10 years of experience in every type of industry you can think of. So right before I'll hand it off to them for some of those really cool real world examples I mentioned earlier, I'd love to kind of get a poll from the audience and understand what's the largest challenge you guys are all facing when it comes to sustaining reliability practices. Is it lack of funding? I'm sure no one's ever had an issue with management not wanting to spend money. Is it maybe aging equipment or infrastructure? Is it insufficient data? Maybe insufficient training, lack of buy-in from a company culture perspective, or even really difficult to qualify the success by the end of the program, seeing if what you put in place actually matters. So I'll leave this poll open. We'll give it probably maybe a little bit more than 30 seconds because I know this one's a little more in depth. Now, if you guys are anything like my customers, I always hear lack of funding, but I'm curious to see if you guys are going to back that up. Based on the fact about half of our group here is doing some form of predictive, I'm pretty excited to see. I bet you there's a lot of buy-in, which is great. Lack of funding. See, I knew it. Lack of buy-in from leadership, and I bet you, category 4 and 5 go hand in hand. Lack of buy-in because it's hard to actually show the success of a program. Buy-in's easy when you can show hard ROI, show quantified examples, and in fact, that's probably a perfect segue to. I'm going to hand it off to my team here and show you guys a few real-world examples with equipment I think everybody will have, regardless of industry. So first one, I'll kind of kick off to Chris here. This was on fans. So I know fans have been prevalent across every industry you can think of, from automotive to cement and everything in between.
Yeah, hi everyone. So yeah, this was a fan in a customer facility. Customer had a long history of fan issues, fans failing. As the slide shows here, over $500,000 of unplanned downtime, and strictly related to their fan issues. They had a preventative maintenance program and what that relied on was pretty much just a lubrication program where they came in and just did routine lubrication, and that there alone just caused over lubrication issues and even under lubrication issues because the program really wasn't followed how it was implemented. I think it had been put in place 5 years prior, and that person left the company. So long story short, we found with multiple fans, we found imbalance, looseness, cracked motor feet, even found scaffolding that was inside the plenum of the fan. That was kind of a huge find for us, but yeah, that just in one of the issues, the result was, it was saved in unplanned downtime was over $200,000. So that was a big win.
Chris, I think I find what's interesting about this one, and you bring it up, is the fact that reliability is complex, right? You can't put all your eggs in just lubrication or just vibration or any one single area, or even just preventative versus predictive. It's really a full program and full mindset, and utilizing all the tools that are on the market to be the most successful.
Yeah, I agree 100%.
Awesome. Paige, perfect. So here's another one. Jaidev, would you mind taking this one?
Sure, absolutely. Good afternoon, everyone. I'd like to zoom out a bit. On this particular asset, I think most of the people that are attending now or that are going to listen to this later on can identify motors, gearboxes, fans, and all such assets. I think the key part with any maintenance program is realizing what the cost of downtime is. And if a particular piece of asset goes down for X amount of time, how much it is going to cost you. In this particular case that we have in a mixer, we had an issue with the blades. We actually had a broken blade, which actually a missing blade, and it had to be replaced. But the key part here is even if you do have, say, vibration analysis that does a monthly route or a quarterly route on these assets, sometimes you'll miss these failures that happen in these assets if you don't have continuous monitoring on your critical assets. So this was one such asset which our customer deemed very critical for them and their operation, and they had 24/7 continuous monitoring of this asset. In this particular instance, we were able to see, the analyst was able to see clearly in the dashboard that there was abnormal vibration that was happening within the gearbox. But we know from years of experience looking at the data that comes from gearboxes and motors, especially on mixers, that if you have any issues down the blade, it can really amplify any issues that you have within your gearbox. And that's what we were able to identify here very clearly, is that there was an issue with the blades for our customer. And we were able to point them directly to where the issue was, rather than sending them on a wild goose chase. So I think this was a very interesting case where we were able to find the issue and fix it well before it became a much bigger problem for the customer.
Great, Jaidev, thank you. And I think this really speaks to a lot of the slides we were talking about earlier, where naturally being able to catch something sooner rather than later is going to result in a much less expensive fix. On top of that, I think it really shows how whether having a reliability or CME on staff or third party can be so much more beneficial. You might have a sensor or some type of technology that's telling you good or bad, but not being able to be prescriptive, and then whereas if you have a CME on staff or third party, they can really dive in, give your team a prescriptive response on how to fix what they're seeing in the data, and they can reduce the overall amount of downtime as well as troubleshooting time. Great. And then gearbox. I think this is something everybody's probably on this call has in some form or another.
Yeah, DJ, I'll go ahead and pop in on this one here and cover this case study. So this was actually a very interesting one. It's one of my customers that I have. Anybody that's in plastics and extrusion knows that, your extruders are the heart of your process there. So this was on an extrusion line, a very old one from the 1960s, an old Black and Clawson setup. And we started monitoring this thing, and we were able to detect within the vibration data. A lot of people call it rotating looseness. Some people call it Type C, mechanical looseness, where essentially you just have a lot of turning speed harmonics that come into play. So with seeing this in the vibration signature, and also one times impacting within the time waveform. So seeing all this within the vibration data, I made a call out, and hey, let's check this coupling out. Let's do a lift test on this gearbox input shaft. So out of that, they had some scheduled downtime that came up to where they were able to identify that, yes, this was in fact the issue. It was some old Hyatt bearings that they had installed on this input shaft, and it was a few thousandths over what the clearance was. The point of contact that I work with this facility is very knowledgeable, so he was able to just on his own go and look up what those radial clearances were actually supposed to be for that bearing, and leverage that data versus what the as found was when they did the actual lift test. So once they had that information in hand, they brought the line back up. they had a batch of raw material, and they ran through that batch, and then naturally brought the line down because they ran out of raw material. And while they were waiting for their next shipment of raw material to come in, that's when they got in on this gearbox and swapped those bearings out, check bore fits and all that to make sure that they weren't going to have any other issues that came into play. And then they were able to get this box back together in time for that next shipment of raw material. So there was no unplanned, unscheduled downtime associated with this extrusion line through this process. They spoke to the fact that previous failures that they've had that would have been similar to what they would have experienced on this one, had it gone really sideways on them, it would have been about 9 weeks or so of downtime for that facility, between all the moving components that would have been involved with that process, getting the box rebuilt and assessing that damage, and hard to find parts because of how old it is and whatnot. So it was actually a pretty significant save for that facility, a 7-figure save. And more importantly, it actually it changed the tune for leadership within that facility. They were kind of skeptical about everything coming into this and out of this experience. Now they have the mindset of, we can't operate without this. So it was a real experience for them, on both sides, being able to detect this for them and work through that resolution with them, and then also, them, avoiding that unplanned downtime.
Awesome, thanks, Eric. Yeah, I think what's really fascinating about this one is naturally they've had this gearbox since the 60s, and it's probably not even the first time they had those issues on the gearbox, but it's really easy for leadership teams to get in the mentality of, we've always had these problems, we've always overcome them by just throwing bodies at it. And it's something we see in every industry, every type of facility. And this is a great example of how they've had this nagging issue for years and years and years. And by actually investing a little bit of money into it, they found a solution that then caused that issue to go away and saw huge ROI benefits in return. So for, I think it was like 27% of you who say, getting buy-in and being able to, get leadership on board, I think this is a great example of exactly that. And if nothing else, I mean, to what Eric said, having parts not able to be easy to get, shoot, I think everybody since 2020 has seen that exactly happen. So that alone, to me, not having to overnight something and get the extra shipping charge, that adds up on its own. Perfect. Well, next we're going to roll into the Q&A with the panel. We'll start off with some of the questions that were sent in early. So once again, thank you everybody who was able to do that, and then on from that. And I know I don't look old enough to have gone to 500 facilities, but trust me, it has happened. That's why I use the younger photo there. So great. Well, let's start with some of these questions. Jaidev, you want to take the first one?
Sure, absolutely. For people who are not able to watch the video and just listening to an audio, I can just read out the question. Can you touch on the different maintenance strategies and the pros and cons? I'd actually like to talk about how to judge a maintenance strategy, and just zoom out a little and talk first about the PF curve. Just thinking about what the PF curve represents, it shows us the degradation of a process, of a system over time. And it is used by people like us, maintenance and reliability professionals, to really judge the relationship between two components, which is one, the potential failure of a system, and the actual failure. And then we can divide the PF curve into various stages to represent that degradation over time. And why I think it's very important to understand the PF curve, and also apply your maintenance strategies over and on top of that. So the main two parts of a PF curve are the P and the F. P being the potential to failure segment, and this segment represents when a system is showing very initial signs of deterioration, of just wear and tear, but there's no immediate impact to output or quality within the system. The second part is F, which would be the functional failure part of the segment. And over here, the component is not able to function at the rate at which it's supposed to, and there's an actual failure that occurs because it's not able to perform its intended function. Now, how can we divide this PF curve into 4 different segments, or commonly 4 different segments? The first one is, I think Vijay, you brought this up earlier. The first one is reactive maintenance. And this involves just addressing failures as they occur without any planning, without any scheduling. And the second one is preventative maintenance. This one's also very commonly used in the industry. This involves doing maintenance or an activity at a scheduled interval to prevent any potential failures from occurring. Predictive maintenance, which is third layer, just moving up the PF curve, involves using a lot of data analysis and condition monitoring techniques, which we pride ourselves with at AssetWatch, to predict when a failure is going to happen and perform the exact maintenance activity that's required. And the last one, the highest part of the PF curve, being reliability-centered maintenance. And this involves going back to the design of the system and making sure that there's no sorts of issues that can occur right from the start, and doing a lot of risk assessments and RCAs and some other techniques. Now, obviously, all of us would like to think that reactive maintenance is bad or preventative maintenance is bad and you have to move up the curve. While it is true that predictive maintenance is probably the best tool that you'd use for all of your critical equipment, it is not wrong to use other maintenance strategies as a part of your overall maintenance goal, because there's some equipment which you may not want to use a predictive tool for to be easy to swap out and easy to change. So there are some obvious pros and cons with, say, reactive or preventative maintenance, but for equipment that does not require it, my opinion would be that you can use those as a part of a successful maintenance strategy overall. I hope I answered your question.
Great, thanks, Jaidev. All right, this is my favorite question, whoever put this one in, and I wonder it myself. So Chris, maybe you could take this. How can you tell the severity of a problem? I know when I look at it as an untrained eye, I see a lot of squiggly lines. So how do I know if it's going to break today, 3 weeks from now? Fill me in, man.
Yeah, so that's it's a great question that we get a lot. Typically, with vibration analysis, the severity is going to be based off of, the amplitude, and the time waveform, the impacting, is it relative to what frequency? Based off of just a generic thing that I say in the field, really is based off of like 1 times turning speed frequency of a motor or a fan. If it's rigidly mounted, then I like to use the phrase of at 0.9 inches per second, you can crack steel or break welds if it's not addressed. Now, if you're looking at 0.9 inches per second in a bearing frequency, well, that thing's going to destroy itself really, really fast, and it's all relative to the speed as well. If you got a rotor that's turning 900 RPM versus a rotor that's turning 3,600 RPM, I mean, obviously the faster rotor is gonna tear itself apart, depending on what type of fault you have. So the severity really comes down to the amplitude and what type of fault is it. Based off of what you're seeing in the vibration data at what frequency.
Interesting. That's probably a good segue, I think, for the next question. What readings do you guys look at typically? Can you give an example of some of the anomalies you look for when you are going through vibrational data? Eric, maybe just kind of mix it up if you mind covering this one.
Yeah, there's definitely going to be just a little bit of crossover, from some of the comments that Chris made there on that last question. But what I always keep in the back of my head when I'm doing any analysis, what are my frequencies of interest? That's the phrase that I keep in the back of my head a lot. So essentially that just breaks down to trying to observe what is of amplitude within your spectral content. what frequency is the impacting within the time waveform spaced at? Does the waveform look electrical in nature or mechanical in nature? Certainly what type of machine train am I analyzing? That factors in. Is this new vibration, or has this traditionally been observed on this machine? Readings that will kind of trigger me to look deeper within the data. Some factors that come into play with something like that is, what's going on with my peak-to-peak time waveform levels over time? Are those staying relatively flat? Are they trending up? Velocity, acceleration trend increases, specific frequencies of interest, are they rising in amplitude? Is the one times rising up in amplitude? Do I all of a sudden have some mesh activity? What do those side bands look like around the mesh activity? Is it a pretty good sizable family? Just a couple that are hanging out there around the fundamental, or even a crest factor that's trending up, off the time waveform. Kind of the gauge that we use for determining the severity of the problem. Is that crest factor data. I covered it when I did the case study earlier. There's everybody's got a wall chart, that's out there, that references, the typical types of anomalies that are out there. Obviously there's, as all of us know that have been in this industry for a minute, there's a lot that is not in the book that you just kind of learn along the way. So you kind of learn your way into those things, but obviously, those wall charts that are out there are a great reference point, especially as you're initially getting into this. What does it mean if I have a high 2 and 3 times turning speed coming into play? That obviously probably thinking coupling misalignment issues. Do I have a high 1 times radial vibration? You probably got some imbalances coming into play. But kind of stemming back to how I started the answer to this question here is, it really comes down to, what are my frequencies of interest? And then you take it from there.
Wonderful. Awesome. Now kind of a question that's centered more around the last poll question. I think that a lot of you are probably wondering is, maybe Jaidev, you can handle this one being a senior leader yourself, but what's the best set of KPIs that can be used to measure the effectiveness of a condition monitoring program, or really any of the predictive programs that we've kind of touched on today?
Absolutely. I'm a big fan of believing that don't fix something that's not broken. There are already a lot of KPIs in the reliability field which you can use, which you can repurpose for online condition monitoring technologies. Obviously, there'll be some differences in the KPIs between what a traditional system would look at and what a more predictive system is going to be looking at. And I can walk through a few of those. The first one is MTBF, which is your mean time between failures. This basically measures the average time between any 2 failure, and it evaluates the ability of a program to detect these failures and prevent them. The second thing that we use commonly here is mean time to repair. So MTTR measures the average time that it takes to repair an equipment after a failure has occurred. But in our space, we obviously don't want the equipment to fail. So you can repurpose MTTR in a way, and we calculate it also as more like a mean time to response. So from the time that we have something on the PF curve, which is a potential of failure, how do we make sure that it does not fail? And what is the time to response over there? So that's something that we measure in-house. A couple of other ones that I think are very useful and can still be used today is cost avoidance or cost reduction. And Eric had a really good point in his case study where I think his customer saved about 1,200 hours of unplanned downtime. And within cost reduction, this is one thing that I think some customers have difficulty in just starting and analyzing what cost avoidance looks like. And there are multiple layers to cost avoidance that you can even start judging a program by. First one being just, what's your unplanned downtime? So if this piece of technology did not exist, how much unplanned downtime would you have if there was a failure that occurred? And that's something that Eric and his customer were able to go back and calculate. And I'm saying it's relatively simple, but it is possible to calculate that value. The second thing is you will know what the cost per hour to run the facility or for unplanned downtime is. And that gives you at least a baseline value of what your cost avoidance looks like. The second part of this that you could add is if you had to replace the entire asset versus replacing just a coupling, like you mentioned about misalignments and the customer losing a lot of couplings. Eventually, it's going to cause the bearings on either the motor or a gearbox or motor and a fan that it's coupled to fail. But if I was to replace only a coupling, it's probably a fraction of the cost compared to a large gearbox or a large motor, then that itself is a cost saving because you have this program in place. And the last one that I think is very useful, and we're slowly helping our customers come up with this data as well, is the number of predictive work orders that are issued. So how many work orders that come out of the maintenance system come out through our through vibration analysis or oil analysis, so that a customer can then benchmark and say, okay, I know that these systems are working, and I get a lot of work orders that come out because of these systems that I have installed at my plant. Now, having listed out some of these KPIs, I'd say the biggest hurdle is just inertia and people not starting. You need to start somewhere. You need to start measuring and evaluating each of these points because, like the poll said, someone higher up is always going to want to know how effective this program is, how much it costs, and how much it has saved. So I'd say start using some of this data that is out there and start measuring somewhere. Because eventually you'll get to where everyone agrees to the numbers that are provided. So that would be sort of my response to what KPIs look like in a condition monitoring program.
Yes, definitely. Always boils down to the money. Did you save me more money than I gave you? Perfect. So next question, I think Chris and Eric already touched on this. So what I was thinking maybe we could do is, Eric, you touched on like the charts on the walls. What if I'm like a new reliability team and we're not really sure how to get those baselines you were talking about it and judge whether or not the readings I'm seeing in any of these types of tools are exceeding where they should be? How do you understand the baseline maybe when you're doing vibration and temperature of a facility or of a piece of an asset?
Certainly. Yeah. So, a lot of people, when they initially get into trying to do some sort of vibration program, they anticipate that they're going to get their baseline on everything. And while it's true that you're starting to gather data, what does that baseline mean? That doesn't mean it's a good baseline. You just start gathering that data right away. Some people stub their toe with that. They think, okay, we're getting this data. This is what is good for this machine. We get installed on a weekly basis at facilities, and we're finding stuff right away. This is wrong, that's wrong. So while baselines are good to build over time when you are getting into this space, that's just, again, it's just go into it with the expectation that that's something that's going to take time. Every machine has its forcing frequencies that it's going to create when there's anomalies present. And what those are is just entirely dependent on what your process is, what the machines are, what bearings are installed, number of components, vanes, blades, number of teeth on the gear. All these things come into play. So, creating baselines for temperature and vibration is something that's really is just going to be developed over time. You're going to get installed. If you get installed and start monitoring this stuff, you're going to find stuff that's wrong right away. Obviously, a motor running an ANSI pump that has high 2 and 3 times. I referenced that earlier as far as speaking to the wall charts. Obviously you probably need to check your coupling and check your alignment. So, and that's where analyzing that content is what comes into play, and not just looking at what's this bar doing over time, is it trending up or down, what is the actual frequency content telling me. So that's really where the meat and potatoes is. What is that time waveform data showing? Are my temperatures trending up and down? What frequencies of interest are in play? What are those related to, and how are those behaving over time? You can build effective baselines, but obviously you'll come into it with the expectation that you're not going to have a good baseline right away.
Perfect, thank you. And then I guess this another question that I saw in the chat. I put on, I think, on the next slide for it. Probably goes hand in hand. Chris, maybe you could help take this one. What's the best types of machines for monitoring? I know that's a loaded question, but say I have a limited budget, where do I start?
Well, I would start with definitely the most critical, things you do not have redundancy on. The most critical is where we want to start, and then you work your way down according to budget. But typically the overall, I mean, just overall machines that we're gonna monitor is really almost every type of stationary rotating machinery. There's a few out there that we don't like to go on that are not good for continuous monitoring, but for the most part it's going to be AC, DC motors, pumps, gearboxes, chillers, compressors, fans, all the basic types of rotating components. But you always want to start with your most critical and then work your way down. I've seen a lot of asset lists where they use numbers, for criticality. Your number one's most critical, and then it goes all the way down to number 5 is least critical. So that's how it really starts.
Awesome, perfect. And
then good FMEA analysis comes into play.
Yeah, good point.
Eric, can you expand upon that?
That's a very involved process. To get that, it's a bunch of if this then that questions that you're asking, mechanically and electrically with your systems and processes. If this occurs, what effect is that downstream to this machine, to this process? Knowing obviously, do you have single points of failure within your system where this goes down, it takes everything down. Knowing those machines, maybe you do have redundancy in place, but perhaps there is some production loss that's involved with that switch, because maybe it can't happen right away. Or it's food industry where you got to waste a batch, even though you are switching over. So, it is a involved process to get an FMEA performed at your facility, but it's very worthwhile in the end, and can even help with some troubleshooting. If things do go awry within the facility, help mechanics out with getting things back up and running.
Perfect. Yeah, I know that's something a lot of guys always try to struggle with is where do I start, right? So that's very helpful. Thank you. And then I saw one come through the chat. I think this was a follow-up for you earlier, Jaidev. A little bit about the looking for more info about the PF curve. So this person said they've seen PF curves all over in their company training, but they've really never understood what to do with them. Is this more of a conceptual tool, or is this something that's built in more of the day-to-day practice used to make calls? And how do you build one and understand, which tools are most effective in that curve?
Sure. Yeah, I can probably answer that. So on the PF curve itself, I would say I can just go back to the definition of it. It helps defining the system degradation over time. So you can basically see if you use, at least for reliability professionals, if you use a particular condition monitoring technology for, say, a rotating piece of equipment, where on that curve are you going to be able to catch a failure? So say you were looking at just temperature monitoring, purely looking at temperature and not looking at vibration. I would say temperature is lower down on the curve. And as you start having a bearing failure, your vibration is going to pick it up first because it can pick up much earlier stages of faults. So then as the bearing fault progresses and it starts becoming something that has a heat signature to it, that's when temperature will be able to catch it. Now, is that piece of equipment very critical to you? If it is, then you're catching it too late on the curve with respect to temperature. And you want to catch it much higher, so you have more lead time to actually work on that piece of equipment, or have a replacement or a substitute asset for that, like what Eric mentioned in his case, where they had time to act on that asset and come up with a solution for it. So I would say the curve is very useful to understand which assets you want to place on that PF curve and say, okay, these assets are very, very critical for me, so I'm going to place them much higher on the curve, and these are the condition monitoring technologies that I need to apply to make sure that it doesn't go any lower on the curve with respect to failure, and I can catch them much higher. Obviously, you don't want to have every single asset up on the curve because think about a light bulb. You don't want to waste time checking out a light bulb every single day, where as soon as it fails, you can replace it. So that's something that you want to run to failure and that you don't mind. So I think it's a thought exercise, and it helps put a lot of things in context.
Awesome, thanks, Jaidev. So I know we got some guests from the mining industry here. So maybe for Chris or Eric, do either of you have any experience implementing vibration into a mining industry, and what are some pieces of equipment you've seen the most bang for the buck or been most beneficial?
I suppose, Chris, I'll go ahead and dive into it, and obviously, feel free to build off of it with any comments that you may have. So, obviously, going into that type of industry, some of the things that are going to be, of interest for you, important pieces of machinery, that can include separators, conveyance equipment, FD/ID fans, boiler fans, so having that analysis done of what's important, for your process, with respect to those machines, all of those are good for the space that you're in with the vibration and monitoring for anomalies, on those. So, Chris, if you want to kind of build on that a little bit too.
Yeah, I mean, all the equipment that you listed, it was really what I was thinking of. So, I don't really have too much to add to it as far as the mining industry goes. Yeah, sorry, I just don't have much to add to it. You kind of covered everything.
Awesome. I know when I used to work back in the day with like Rio Tinto and Kendicott Coppers, I mean, it was a lot of big old pumps, a lot of giant gearboxes running those grinders and those crushers. Those things always seem to be going out just because the amount of stress and force that they're taking. A lot of the critical pumps for like cooling flow. So, shout out to Utah if anybody's here from Utah. And then next one, I think Chris, you might have been one to talk about this. Somebody had asked a question. What does it mean if I see gear mesh frequency in my motor spectrum?
Yeah, if you see gear mesh frequency, so typically just seeing gear mesh frequency isn't necessarily a reason for alarm. If it's just the gear mesh frequency that's dominant and you see harmonics of that, it could just be related to load. However, when you start seeing gear mesh and really what you're looking for is the side bands, the amplitude of the side bands. Rule of thumb is that if the side bands are 50% of the amplitude of the fundamental gear mesh frequencies or the harmonics, then that's when you can really tell that a defect or an issue is developing. Another thing obviously is to look at the impacting in the time waveform and see how much impacting you have. But with getting continual data, we like to look at the amplitudes of the actual gear mesh, and if those amplitudes fluctuate, it's usually just due to loading issues, not necessarily an issue, but just load changes.
If I may add to that, actually, looking up on the PF curve, if you actually collect regular oil samples from a gearbox, you can see the fault progressing or happening also. So say you have the wrong type of oil, you mix the wrong type of oil, the viscosity is incorrect. Things like that will start showing up. Go ahead, Chris.
Yeah, I was just relating to the actual vibration and not oil, but that's a really good point if you're utilizing oil analysis.
DJ, I want to circle back. Was the question on if you see the mesh in a motor?
Yep. So in my motor spectrum is what I read in here.
Oh,
Gotcha.
Okay. Yeah, so typically, if I'm going to see gear mesh developing or showing up in a motor, my first instinct is to think of, what type of coupling is it? If it's a rigid coupling, then those frequencies can definitely transfer through the shaft, but they'd be kind of strange. Is the vibration directional at gear mesh? I mean, is it related to a resonance potentially? If I see it in a motor, typically I'm trying to find out some other information. If it's not present in the gearbox itself and it's strictly showing up in the motor, then that's another thing we'd have to really kind of figure out what's going on there. Do you guys have anything to add to that, Eric or Jaidev?
Yeah, you definitely touched on it as far as a coupling type is concerned. I mean, gear couplings can present some interesting spectral patterns that may look mesh related. So unless you know those tooth counts within that box, if you have a gear coupling, maybe that's what's actually causing some of that signature that you're seeing within the motor.
Good point.
So.
Yeah, I'd say it's not uncommon to see forced vibration, especially if the fault is deteriorated to a point where you can almost hear it. You're probably going to see it at the motor also, some bit of it, because the sensors are very sensitive. And
it's probably safe to say that's where continuous can be a lot more effective than like a route-based solution, because you're having more data points. And when it comes to anything, it's always better to have more data than less data to be able to work out some of that noise.
I agree with that.
If anybody has any more questions, I think we're going to wrap it up. And but I appreciate everybody asking the questions and sending those in both during this chat and after. If you have more questions, feel free to send them in. We'll definitely get back to you. Every one of these CMEs have more experience than the Yankees have titles, so feel free to reach out to us, and we'll be happy to get back to them. Paige, I'll let you kind of wrap things up from here.
All right, perfect. Thanks, DJ. And thank you, everybody, all of our panelists, for your wonderful input. It's very rare to get folks of such good caliber all in one kind of webinar space. So we really appreciate you guys all taking the time out of your schedules to be here today. And also, just on behalf of our entire team here at Mobius Connect, I just want to say a big thank you to our wonderful audience for tuning in and for asking all of your questions. Like DJ said, if we didn't get around to your question today, we will make sure to follow up with you via email to make sure that your questions do get answered. Just as a quick reminder here before you guys jump off, the recorded version of today's webinar will be made available on CBM Connect, and you'll all also receive it in an email tomorrow as well, along with your certificate of attendance for CEUs for joining us today. If you'd like to, feel free to share that certificate up on LinkedIn, tag AssetWatch, tag Mobius Connect, tag our experts that are here today, tag me, tag everybody if you'd like. We'd love to see those. We love to support you guys all on your educational journey. So feel free to share those certificates once you receive them. And then if you guys are interested in engaging with other industry professionals, or if you'd like to participate on the industry's live feed and ongoing forum discussions, you can do so at Mobius Connect, which is mobiusconnect.com. You can also follow us at Mobius Connect on all major social media networks to stay up to date with all of the latest and upcoming webinars, latest content. More from AssetWatch will be coming there, so be sure to follow along. And if you guys have any questions whatsoever, you can email me directly. My email address is paige.hattie@mobiusinstitute.com, or you can reach our team at info@Mobius Connect. We'd love to hear any suggestions that you guys have, other topics, other questions. So feel free to reach out to us either via email or on LinkedIn or in Mobius Connect. But thanks again, everyone, for joining us today. Have a great rest of your day. Please stay safe, and we will see you all next time.